Have fun, man. Enjoy.
It works.
Is
Nice.
the screen sharing?
Yeah, should be.
Yeah, there it is. Go ahead.
Well, hello everyone. There's a lots of people. I haven't seen that many people in one room in a very long while. Wow. Hello. Yes. I'm gonna explain a lot about my experience, and I hope you can share in this experience. This is me. I'm Joost. I'm a passionate software craftsman. I develop mostly JVM and browser stuff, and I'm an independent consultant and contractor. I also, up to I think 2 years ago, were a very vivid, no, what's the word? Passionate organizer for Kotlin and Scala meetups here in Amsterdam. And well, you can reach me on this address. First, I have some assumptions about you. I hope you can have this sort of base knowledge, and if not so, please ask me to explain some of the stuff, but I can't explain all of it because we don't have that much time. I will tell you where my experience is from, and then I will show you the different technologies we've used with together with Kotlin, and show you examples of how we used it and the stuff that's the fun stuff we had with it, and the gotchas we encountered. So my assumptions is that you have a basic understanding of a Java backend life, or so you have some development experience with the Java ecosystem and developing stuff in this ecosystem. I think it sort of also applies if you have Android experience, then you are also in the Java ecosystem. And yeah, I also assume you have some familiarity with the Kotlin syntax. So if you have any questions there, please ask, but I can't explain too much. So I boldly claim I have a lot of experience with Kotlin. This experience is from my current contract where I work for Ballcom, where I joined 2 years ago in a very ambitious project that wanted to replace or actually insource a piece of software they have been using for 10 years now. And there was an end of life on the environment this software ran in. So it either needed to be rebuilt by the third party that supplied this, or some guy within Ball.com said, like, we can also do this ourselves. So we started out with a proof of concept to show that we can do it ourselves. And that sort of grew into more. Yeah, there's a key part of this is that we're insourcing a very important part of Ball.com. And we have a very strict deadline that the other software stops working at a certain deadline. But apart from that, it's a greenfield project where we just go. Yeah, given the current situation, all of it was remote in the beginning. Everything, like we sit in a video conference all day, and we emulate sort of office experience there. And we got to see each other after a couple of months in real life, and well, it sort of went up and down given the situation. We started out with 6 people. These 6 people were a couple of developers and some business analysts, and this quickly grew into 20 and even 40 people now. And this is a project of a lot of seniors who are very passionate about building the best thing for Ball.com. And yeah, this has been a very nice experience, nice culture to live in and to build in. We've been using a lot of technologies. Here I have a list of all the different technologies we are using, and I probably have forgotten half of them. There's many more technologies we have been using and I've had experience with. And I will go through some of them at a time and show examples of how this works out for us. So, to start, Ball.com is a Spring company. Everything is, well, most of it of software development is built in Kotlin in Spring. And the good thing about Spring is it has a very nice interop with Kotlin. It has a special DSL, special syntax and helpers, which are completely invisible if you are developing in Java, and they suddenly appear if you switch to Kotlin. And that makes for a very nice experience. We are using Webflux, but we're not using the full DSL for routing and all the other stuff, but we're just using plain old Spring kind of things with the annotations and components everywhere, and it just works, and that's very nice. Where it just works has some side notes. So far, the Kotlin has been a lot of fun. It's not perfect, but it's a lot of fun, and I have a lot of experience. I gained a lot of experience, and I think I've really enjoyed it. Within Ballcom, there's also a lot of experience with Spring and Kotlin, and this is also a very nice environment to operate in. They have their own homegrown parent project, which gives you a lot of batteries included stuff, where you can just start a new project and it works in their environment, it works in their cloud environment, and you don't have to think about all the details. The only thing with their framework is that it works on Maven, and my experience with Maven is it is tremendously slow to compile stuff in there. So that annoys me from time to time. Let's take an example here. This is how easy it is to start a Kotlin project with Spring. In the middle, I can actually use my clicker. We have the main function and an annotation on a random class, and we start our application. That's all we need to start, and then we can start building REST controllers, like is shown on the right, on the bottom right, and we can start building a web server. So not a lot of boilerplate to start out with, not a lot of rituals. You just get going, and you're happy, and you can start delivering business value. My biggest love of Kotlin is the extension functions. I have tried sort of extension functions in different languages. The top one is Kotlin. The middle one is how you would do it in Java, where it is not really possible. So you get static functions everywhere. And the bottom one is the one which is in Scala, and actually the one in Kotlin is the least friction. It's so easy to use. It has made me happy, and I've used and abused it everywhere. So yeah, and I can just create whatever I want. I can do higher order functions. They all are first-class citizens in Kotlin, and happily do my thing, and don't get caught up in all the language rituals you have to do to make something work. More function love. You can do weird things as storing a function in a variable. You can create operators, sort of, with words, or if you use the magic names, you can actually do operator overloading and do infix operators. And a surprise that came up was that you can call something list with a capital L, and then you get a iterator or sequence kind of thing, and do stuff with it. It's all kind of nice things you can discover in Kotlin, which some of your colleagues are just doing, and then you go like, oh, you can do this too. That's very nice. And but yeah, Kotlin can also have weird syntax. Like the bottom object extends my interface is how you create an anonymous class, which has surprised all of my colleagues every time they encounter it for the first time. It's weird, but it makes sense if you know how Kotlin is built. There's a lot of nice help in Kotlin. On the left, you can see how I embrace the nullability and use the special question mark dot operator and a let and a Elvis operator to actually just fold like I used to do with an option in Scala. And I use this pattern a lot, and it makes it so much easier than doing if checks and stuff like that. And on the right, we have a random example of the library functions that make creating data much easier. and the data classes, of course. Yeah, one of the things that sort of was not so nice is when. Like when is a much better switch, but it sort of supports some of the things you expect to do with pattern matching, which it sort of emulates. And you can do when with the subject, and then you can match against it, and then it works. But then you can't do the extraction you can do elsewhere. So in the middle example, I'm trying to extract my tree, which is a data class, which I should be able to extract in the match part of my when, and that doesn't work. Okay, I'm used to doing this from Scala, and it makes a lot of sense to be able to do it in here, but yeah, the first time you try, going like, oh, that doesn't work. Okay, sure. And then you have the bottom version where because the when sort of has no keyword for each of the cases, you either operate on a subject and you can only do one test, or you can do a combination of tests, but you can't use a subject, and then you need to use the name again and again. Well, given how Kotlin is built, I would expect to be able to use it, like here. That would have made a lot more sense. Yeah, there are other quirks in Kotlin where if your last parameter of your functions happens to be a higher order parameter, a function, then suddenly the syntax changes. Like I write a lot of functions which take more than one function as an argument, and then the last one has different syntax, and then if I want to pass a function reference, then suddenly the syntax reverses again. And yeah, this is one of these things that it makes sense that they tried it like this, but it gives very awkward conversions back and forth if you when you're refactoring code. But yeah, it can be nice to be able to write sort of control structure like syntax. Sorry. There are nice gotchas in the Kotlin syntax. Kotlin actually transpiles to Java bytecode, so it inherits some of the things you know from Java, but it also can be very confusing. This is an example of where I make an inheritance tree, and actually, luckily, IntelliJ warns you about this, but I got this question a while back where one says, okay, I created this parent thing, it takes a parameter in the constructor, and then in the construction init I print the value, and then I override it, and I do the same there in the construction of the child. I also do the same thing. How come that the first print line gives a value and the second one gives null as an answer? Then this happens to because Kotlin translates property access to a get method, and even though it looks like test at the top is in scope of the constructor, it is actually not. The constructor, the test you write there is translated to the get test, which is a member on the class which is not initialized yet because we're in the constructor. So this gets all kind of weird stuff going on. So sometimes the Java translation stuff leaks out. But yeah, there are quirks. Every language has their quirks, but it mostly is a very nice language to work with. In Spring, we of course want persistence. Most applications have state, so you want persistence. And we started out with Hibernate, but quickly switched to Kotlin Exposed, which is a persistence framework built for Kotlin. So it's much more idiomatic Kotlin to work with, and makes it much more natural to continue the functional thinking, the data oriented thinking you get used to in Kotlin. We used it with Postgres. I think everyone knows Postgres and uses Postgres if they are in some kind of environment. And we use Flyway to make it very easy to just build up our state. Yeah, so that all worked fine, but the Kotlin Exposed is a very young library. It has weird DSL syntax where you get confused quite a lot, where you get the feeling like, okay, this is actually not a 1.0 and absolutely not a 2.0 version of this framework. And it's probably could have been done better given you have experience with how you actually use it. And the documentation for it is quite scarce. It is a new framework. There are not a lot of Stack Overflow questions and answers on this. The documentation itself is very sparse, and they introduce new features which are not in the documentation examples yet. But yeah, in the end we figured it out, and it worked quite well for us. We've been quite happy. So let's take an example here. Here on the left, I create my small table with my flyway script, and then on the right, I create this syntax where we create a table, then create a repository where we use the table, and then you get confusing stuff like I'm going to do a where clause on my table, and I need to use the word select, which is really confusing at first. And then you need to select columns. And then you use something called a just slice, and if you start to doing inner queries and joins, then suddenly you need to use aliases, because the framework gets confused which column needs to be mapped to which part of the data. So yeah, I have experience with very fancy frameworks like Slick in Scala, which took a while to get sort of right, but these kind of things they figured out by now. So yeah, it would have been nice if they could have built on this experience instead of having to like reinvent the wheel again. And apparently nobody has noticed that the query returns an iterator. Everyone just maps over it, which in Kotlin is a library function which turns the iterator into a concrete list. So suddenly all your results are pulled into memory. So be mindful that you can actually also stream data from the database. On the bottom you see the toDomain function. This is a pattern we have, I think, invented at our project, where we always have the result row which you get back from a query extension function, which just converts it to our domain object, where you can read it and then and then can use it, which has worked quite well for us. Only the alias thing is weird, because it tries to abuse the array notation to access stuff, and then you do array notation into a thing, which then does array notation in another thing, and then if you would make alias optional, then you have no clue how to do this without building big if-else structures. So yeah, weird syntax. So let's go to the next part of our stack. If you do a web framework on Webflogs, of course you're very mindful, you need to be reactive and don't block on stuff. So you have two big significant options in Spring. You can either go for the project reactor stuff, which is like homegrown by Spring, where you use monos and fluxes. Or you can go for coroutines, which Spring also happily supports. Our team started out with a lot of senior developers, but with not a lot of experience with Kotlin. So they actually felt more at home with the project reactor stuff than with the coroutines. So we started out with using that. But yeah, project reactor is sort of the Mona thing that you get confronted with all the boilerplates. You need to be able to operate on these kind of things, where you lift these kind of effects into the types. And you need to learn new DSL. You need to know what map means. You need to know what flat map means. And also they have some weird behaviors. Later, in newer sub-projects we had, we were building a microservice environment, so we started extracting a lot of services. In newer services, we started looking for, into coroutines, and it turns out it gives you very nice code. But yeah, somehow some people are scared of it. So you need to have a good argument about this and make a lot of people happy, so that they know the coroutines are very nice to work with. Both have very weird gotchas, and well, even though Kotlin promises to have full interop with Java, some stuff doesn't work, and you need to figure out how to work around this. Why did I put in cannot block on main thread? Ah, that was a nice one. Right. This is not a gotcha, but a nice thing actually. The Spring framework or the Reactor framework, it warns you if you try to block on a main thread, because, well, that's one of the framework's threads. You don't want to block it. And it just happily says, hey, you're trying to block on a main thread. This is not allowed. So that's very nice. And that sort of catches the gotcha where you didn't allocate a new thread pool for blocking work. But the other thing is that you can't block on the main thread. So as soon as you're in an environment where you can't return a mono or a flux, you're stuck. You can't break it. And then you need to sort of figure out, you need to actually allocate it on a different thread pool before it works. So here I have an example of, I did my nice work in Flux. I wrote I had a list, turned it into a Flux, and then I flat mapped some work in it, which is also a reactive function which calls out to some server somewhere. And then I just flat map it, and it works. And for the mono example, where I just get one value, it's more simpler. But I need to learn this new syntax. I need to learn flat map and map. Once you have learned that this just works. You can do everything you want. If you go to coroutines, then the first thing is you try to translate it, and then I go like, okay, I don't have a flux, so I can keep my list. I don't have to translate it, and I'm going to flat map work in there, and I just add some suspend keywords, and then the compiler says no. It refuses to accept this because flat map is part of the standard library of Kotlin, which is like old school kind of without any coroutine stuff. And the function I'm trying to shove in there is not a normal regular lambda, but it's a suspend lambda. And then it turns out I fall back to writing a for loop to get through this problem, because I can't somehow inject a coroutine scope in there. I haven't found a way to work around this. I just had to fall back down to basic for loops here to get this to work. The mono example at the bottom is very easy now. It's just string interpolate the value into the string, and then add the magic suspend keyword to the function, and then voila, compiler is happy. And I think this makes a much more legible code in general, but sometimes, yeah, you do have to work around that. Coroutines don't always interact with other existing library stuff. At Ballcom, they have been very hard trying to transition from a data center to a cloud environment. When we were starting there, we really just, we started in the beginning of the transition, and we looked at the cloud environment and it didn't work. So we started out in a data center, and we started out with a 1 month proof of concept. So we had no room to just go fiddle and try and wait for them to finish whatever they were doing. So we built a monolithic application which was prepared for splitting out into multiple services by using the submodules from Maven, and having each of the modules communicate through REST or through messaging. And this for us proved out to be a very good strategy, because as soon as the cloud environment became ready for different kind of things, we could start split out the work. We had some part which didn't need persistence, and the persistence wasn't ready yet, but we could already start operating services. And this was for us a very good strategy, and it worked quite well. And Ballcom also provides a lot of extra tools for us to happily use the cloud environment without really caring about provisioning and getting stuff communicating and punching a hole through firewalls and connecting up the networks and stuff like that. So that worked out quite well, and I think it's a good approach. If you start a new project and you're doing proof of concept, just build the monolith, but keep in mind that it needs to be modular, and then you can build like crazy. When after a while, we figured out we wanted to do GraphQL for our front end. We built all kind of services that were happily communicating through REST and messaging, and at a certain point it was like, yeah, we need humans to operate on this system, and we started adding a new service, which then exposed a front end, and tried to figure out how to use GraphQL. And to do the GraphQL, we actually looked at 3 different libraries, the Netflix one, the Xebia one, and the Apure-based one. And we eventually settled on the Xebia one because it was most Kotlin-like, and it fit our needs at most. Like the Netflix one is much more Java-like, and is actually schema first. And we wanted to have code first and generate the schema. And the Xebia one allows for both. And the Xebia one has very nice Kotlin support. It's actually built, well, it has Kotlin in the name, so it was built for Kotlin. And then we also tried the Apure-based one, which looked very nice, but seemed dead. There was no activity on their GitHub page for, I think, half a year when we started out, and looking back, it has been dead for 2 years now. So that was a very good choice to do. Yeah, and I can fully recommend this GraphQL library. It interacts sort of nicely with Spring. I think it works better with what is it? Arrow? No, Kotor. Sorry, the other one, Kotor. All the examples are written as though you're going to do the Kotor version, but it actually you need to configure like a small thing in Spring, and then it just works. And then you can happily use all your annotations, all your components, and instead of having to force the functional DSL kind of thing approach they have in Kotor into Spring. And it just generates schema code, and actually on the client side we use Apollo in the browser, which then happily reads in the schema again and generates all kinds of TypeScript magic, and we are fully type safe. The one thing I have with GraphQL in general is that it has no knowledge of generics. This is a complete pain if you try to serialize a map. Like, you need to create your own map-like thing for everything you come up with, and there's a lot of generic things, like we have a lot of paginated results, so we have a paginated object, and it no work. But yeah, apart from that, GraphQL in Spring and Kotlin is a very good mix. Yeah, I show you in the center, I show you how you write a query. You say, I have a component, this is my query, it extends the query thing, and that makes the Spring magic pick it up. And you give it a function. You can make a suspend function because this is fully Kotlin aware. And you need to return this magic thing called the data fetcher, which can either hold a data or an error or both. If a sub part of your tree fails, and it just works. It generates a schema for you where it really looks like a schema. You can't really see it on the top right, but here we have the GraphQL playground, which is available to most GraphQL projects. We can just go query the language, it shows you the schema, it does syntax completion for you, and that's a very nice experience. And on the bottom right, you see the weird syntax the helper function I generated to created to be able to translate from our generic object to a specialized version of a class, where I can give it the constructor to a class, And then at the bottom you see I have my data, which was a page. I turn it into a paginator through my nice extension function I created. I give it the constructor for my specialized page thingy, which then loses all the generic information. And I feed it a function to actually also change my domain class per element in the list to a response object. And here you can see how Kotlin shines. It can solve most of your weird problems with just a bit of extension function magic. Very, very nice. Yeah, and the last part, I don't know if you're interested in this, so I didn't include examples here, but we worked with TypeScript, React, and material design in the front end. And oh, she caught me off guard. And here TypeScript shines too, with using GraphQL, type safety, and you can just happily go along, develop, and the compiler just shouts at you if you do something wrong, which is very nice. And the only thing about TypeScript is it is so much more complex than a Kotlin would be. I argue it's way more complex than Scala is, and some people find Scala complex already. And me knowing Scala, I can happily program in it, but some of my colleagues are surprised by the things you can do, and think you write sort of a token soup if you use some more advanced constructs from TypeScript. So here you have to really be mindful, don't overdo it, because people get confused quite easily. And also, it is very, very hard to debug errors. Kotlin compiler can also give some weird compile errors, but the TypeScript compiler is way worse. I actually didn't want to include the example, but I think I can show it again because I have some time left. At the bottom right, you see this is a compile error. This reminds me of when I was doing Scala in 2007, when the Scala compiler generated these kind of errors. Nowadays, it just tells you what's wrong instead of going like, yeah, somewhere in my parsing something went wrong. So yeah, that was fun, and we used React because we're functional programmers, and React is way more natural to functional programmers than the other stuff. And we have some very simple, it's called a Toussaint library for state management, and that interacts nicely with the rest, and we're happy. The only downside of TypeScript is it's not just complex. The compiler also thinks it's complex because it's very slow. It's way slower than the other stuff. So it was summarizing. It's a very nice place to work at Ball.com. In this kind of greenfield project, this environment has been a great experience for me learning Kotlin. Because before this project, I played around with Kotlin. I had like these toy projects. I actually taught Kotlin to a lot of people at the meetups, but I never had this really good experience of what kind of friction you would encounter if you built like real world, really big projects. It has been a great experience. I've learned a lot of new cool technologies. I've learned to work with Spring again, which I hadn't been doing for 10 years or so. And in the end, everything is a compromise. The Kotlin has been a very good enabler, but it has its downsides. I wouldn't pick anything else at this point. And the GraphQL thing was also sort of compromised. The Kotlin Exposed is also sort of a compromise. But it's the best thing we could find, and I think it is way better than most other options we considered. I like the culture and the support I get with there. So any questions about Ball.com or the technologies we used and the assumptions and conclusions I had about them? Do we need to give you a mic?
Yep. I was wondering.
Flimsy.
Okay. I was wondering, you chose for Exposed because you didn't choose for Hibernate. What were the reasons why you chose Exposed? That's for one. And second, could you then name two really benefits you had choosing for Exposed, and maybe also two drawbacks compared to Hibernate? I'm kind of curious. I mean, I know Hibernate's a lot of black magic, but did it really get so much better? I would like to know a bit more about it.
Yeah. Yeah, so we chose Kotlin Exposed over Hibernate because Hibernate doesn't map well on a relational database. We dropped down to writing, well, plain SQL instantly. And then you get the choice, like, do we just use JDBC then? And then we went like, no, but we're doing Kotlin. People have nice stuff for this. And I can't remember which we tried, but we tried several different approaches. Yeah, also have like this, who is it? Verbatim, no. My Batis kind of thing, where that maps way more on record-based thinking on the database. But yeah, Kotlin Exposed is a way more elegant way in Kotlin to have this record-based thinking and build with this and just use functions on it instead of you having to like write your own strings and concatenate them together. You have actually sort of builders for generating your queries. That was, I think, the biggest reason we chose it, because it just maps onto the database and it allows for more builder kind experience, which you might know from my Batis. Okay.
No other questions then?
Oh, I have a question to you.
Go ahead.
Are you all already doing Kotlin now, or did I convince you somehow? Do you want to do more Kotlin? Or do you all go like, oh, the guy's insane, I'm going to do Couture, the weird guy.
Let's see some hands for who's already doing Kotlin. And let's see some hands for who wants to do more. Those can be the same hands, yeah, obviously. Yeah.
Well, they were less enthusiastic than the first then, so I think half of you are experiencing some of the frictions then. And yeah, so what do you feel? Do you agree that Spring and Kotlin would be a nice thing to just get stuff done, or?
We can have a chat with that in the break that's coming up.
Yeah.
So at 4:45, we're gonna have the last talk of the evening. Did we save the best for last? I don't know, but you'll find out in a bit. So we'll see you then. Cheers.